The overall goal of this procedure is to fabricate a multiplexed microneedle-based sensor for transdermal electrochemical detection of various target analytes that can be simultaneously measured. The first step is to fabricate hollow microneedle arrays using microstereolithography and create electrode array cavities using laser micromachining. Then prepare the individual carbon pastes and fill the electrode array cavities. Next, calibrate each of the carbon pastes over a range of physiologically relevant concentrations. Ultimately, a transdermal in vivo electrochemical device is created that is capable of simultaneously measuring multiple analytes in complex physiological microenvironments for a range of biomedical applications.
The main advantage of this technique over existing methods is the ability to perform multiplex sensing in a minimally invasive manner.
This device can be utilized as a research tool to measure acute medical responses, gain understanding of adaptations during physical exercise, and monitor illnesses that affect the skin. The implications of this in vivo microneedle sensor extend towards diagnosis of skin tumors, because tumor microenvironments can serve as indicators of tumor proliferation and metastasis.
Our goal with this device is to use microneedle arrays as a minimally invasive mechanism to access dermal interstitial fluid for electrochemical analysis.
Begin in the three-dimensional modeling software SolidWorks and design a pyramidal-shaped hollow microneedle array. Then, using the Magix RP13 software, design a support structure that provides a base on which the microneedles are built. Next, control the fabrication process using the Perfactory RP software. Upload both the linked support and the microneedle array files. Then select the number